Today we take another run at adding Wi-Fi to your 3D printer, only this time I think it's going to be a whole lot easier. A couple of years ago I did do a video on adding Wi-Fi to your 3D printer, but it wasn't that straightforward of a process. You have to get your IDE set up just right with the correct libraries and get everything wired up to be able to flash it and then install it on your 3D printer. With the release of the BigtreeTech SKR 1.4 boards, those come with a Wi-Fi port, so they're really easy to set up with an ESP8266 module, just like we used in the original video. This is your standard SKR 1.4 board. The Turbo and the 1.4 are going to be exactly the same as far as Wi-Fi. This is the port you use right here. There are a lot of different sellers that sell these ESP8266 ESP01 modules. These are the 1 meg chips. You can still use these smaller modules. You can get them from BigtreeTech as well, but they're all going to pretty much work the same way. The module will install on your board just like this and hang off the edge. You can also install these modules on the touch screens. This is a BigtreeTech 3.5 version 3 screen. They also work with the MKS screens as well, but you can just put those ESP modules on the back. The modules will point to the outside of the board. They just go in these pins right there. BigtreeTech also sells this writer for just a couple of dollars, and this thing makes flashing those ESP modules way easier, and they even provide the jumper wires so you can hook up to them. So that's what we're going to be using to flash ours today. So now that some of the SKR boards have a dedicated Wi-Fi port that support 3.3 volts, because these ESP8266 modules can't tolerate 5 volt, as well as the writers that will support 3.3 volt, it makes these installs a whole lot easier. But it's important to note that the ESP3D software that we used in the original video is the same software we're going to use today, and that is what makes this whole thing work. The guys over at ESP3D have done a ton of work since the last time that we tried this install. They have added a ton of new features, and quite frankly, the software just looks great. Here's a screenshot of the web GUI interface. It's well laid out, pretty easy to use. And without this software, this whole thing really doesn't work out all that well. So the ESP3D software is the real jewel here. It's what pulls it all together and makes it functional. And there is some setup that you have to go through in Marlin to be able to use one of these Wi-Fi ports. And I want to thank Warkocki for doing a lot of the legwork on this setup. I got a lot of the pin numbers and things from him to be able to make this whole thing work. So today I'm going to walk you through step by step how to get all this set up and connected with Wi-Fi on your 3D printer using an SKR 1.4 board and an ESP8266 module. So before we get started on configuring the software, let's go over how to set one of these writers up. You don't have to use this writer. You could just use an Uno board like I did in the previous video. You can check that out there. But I think the writer is well worth a couple of bucks, so if you're ordering an SKR 1.4 board, definitely have a writer thrown in as well. These writers can do 5 volt and 3.3 volt. The ESP8266 supports 3.3, so that's what we want to use. But you could use 5 volt, for instance, if you were trying to flash a 2560 or something like that. My board came configured with 5 volt with this jumper on these 2 pins. We want to make sure it's configured for 3.3, so we just move the jumper over to these 2 pins. The wires that they give you, the color doesn't matter, but I am going to kind of work left to right so that it makes a little bit more sense and I don't have to pull these wires apart. So my brown wire, I'm going to attach it to ground, this pin right here. You can use either one of these pins, whichever one you'd like. My red wire, I'm going to attach it to the 3.3 volt pin right next to it. I'm going to skip the 5 volt pin, the one right next to that, and I'm going to go to my receive pin. It says RX0 on it. I'm going to use my orange wire. And the pin right next to that is the transmit pin. I'm going to use my yellow wire right there. And then on these pins up here, this first pin over here, that's the reset pin. I'm going to use my green wire on it. And we have a pin next to it that's labeled DIR, but this is going to go to our IO0 pin. I'm going to use my blue wire on it. Then on the ESP side, my brown wire, remember it's connected to ground on the writer. We'll go to the ground pin on the ESP module. Red wire, 3.3 volts. We'll put it on the 3.3 pin right here. My orange wire is on the receive pin of the writer. It needs to go to the transmit pin on your ESP module. They're flip-flopped. Yellow wire is connected to the transmit on the writer. It needs to go to the receive pin on the module, right up here. Our reset pin is on the green wire. The reset pin is right down here. And then that DIR pin, the one we used on the blue wire, that needs to be connected to IO0, which is this pin right up here. And those are all the connections to get set up to use your writer and your ESP module. Now, for this video, I have deleted all of my VScode folders, uninstalled everything, as well as my Arduino IDE and those local files. I think it's important that we walk through the VScode install real quick one more time, because we are going to have to alter some Arduino framework to make this whole thing function. It's not that big of a deal, it's not all that scary, but I think it's a great time to run through the VScode install as well as the PlatformIO install, just to see if it helps others out. So let's open up a browser. We're just going to search for VScode download, and we'll head to codevisualstudio.com. I'll do this pretty fast, you can skip ahead if you'd like. I'm going to grab the 64-bit version for Windows. Once the download is complete, I'll just click to open it. Agreement, next. Default location's fine, next. Hit next. We'll let it add our environment path. You can also tick some of these boxes. This will let you open files with a right click in VS Code if you'd like to edit them there. It's kind of handy, so I'm going to go ahead and take these top two. We'll hit next, and we'll hit install. We'll hit finish, and we'll launch Visual Studio Code. We are here in VS Code, but we need an IDE to be able to compile the Marlin software, as well as the ESP software. So we're going to head to Extensions, over here on the left, and we're just going to search for PlatformIO. And you want the one that says PlatformIO IDE. We'll just hit install. In the terminal down here, it's going to install the core. Just wait for it to complete. When it's done, we will need to restart VS Code. We'll just go ahead and hit reload now down here. And when it's successful, you'll see the PlatformIO home up here. You'll also have your alien icon over here. We'll jump back to the Explorer up here in the corner. And now we need to go out and grab the ESP3D software from GitHub. So we'll just search ESP3D GitHub. It's this Luke GitHub right here. And I just like to grab the latest stable release. So we'll go down here, it's release 2.1. We'll click this, and I'm going to grab the source zip right here. There are some warnings here that the software is over 500K. We have a 1 meg chip, so we do need to make some modifications to get it to fit on that chip comfortably, but I'll show you all about that in a few moments. So let's head to downloads, and we'll just extract all on that ESP zip file. We'll just hit extract. Once it's extracted, let's head back to VS Code, and we'll hit add folder. We'll go to downloads, that ESP folder. There is an ESP3D 2.1 folder inside that folder. We don't want to add the parent folder. You want to add the folder that has your .vscode in it. This is where your project lives. So we'll go up one, single click this folder, and hit add. If you don't have your alien icon, or when you click on this folder, if you can't remove it from the workspace, you have the wrong folder. It doesn't have the right files in it. So check and make sure you're adding the right one. I'll just close these PIO homes, and we want to expand the ESP3D folder right here. And all of your configuration changes are going to be made in config.h, so we'll open that up. By default, the ESP3D software is configured to use an ESP8266, but you can also use an ESP32, which is kind of the new flavor of chip. It's much faster, has a lot more memory. These are the old school 8266 modules we're dealing with. Again, they are 1 meg. For our configuration, all of these defaults in here are just fine. The only thing we need to change because of memory issues, I'm going to disable the notification feature. So I'm just going to put a comment on line 52 right here. This is a feature that allows you to send notifications to different applications. I don't intend to use it anyway, so it's not a big loss for me. But if you want to use it, you're going to need a bigger chip than a 1 meg chip. They do make 4 megs if that's something you want to check into. Now that is the only change to the software that we need to make to be able to use it on our chip. It should work as is. We will need to make an update to the platform INI file. So let's head into that. We'll scroll down to the bottom over here in the Explorer. And we'll do platform INI and we'll take a look. Each project is going to be configured with its own platform INI file. That contains all of the environments that will work with the software you're working with. This one has ESP32, And then down a little bit lower, it has ESP8266. Now on these boards, you can use what I would like to call a side file. It's a file system that you can access on the board. So half of the memory on this board, we're going to divide it up for the application, all of this stuff up here, and then we're going to take a piece of it and use it as a file system and load our files for the web browser portion. That's the UI, the part that you see when you load it. And to decide how big your chip is and how you want it divided up, you do it right in here. Now this is the old syntax for doing this, and I'll show you that in a second. We do want to update to the new version just to keep things consistent. But what you would do is you would change this to the amount of flash memory you have on your board. So this one is for a 4 meg with a 2 meg file system. We have a 1 meg chip, and I'm going to use 256K of that 1 meg as my file system. So I just removed that 2M and put in 256. You don't need the K when you're dealing in kilobytes. So again, 1 meg chip, 256K file system. And that should be all you have to change to tell it what board we're using. Remember, these are the ESP01 modules. And now that we have that updated, we should be able to build successfully. So if you head over to your alien icon, you'll see we only have 2 environments available up here in the project tasks. We are in the 8266 environment, and you can hit build. VScode is so much easier because it pulls in all the libraries you might need for you as it's building. Unlike in the IDE where we had to go find all the specific versions to make it work. You can ignore anything in yellow, that's just giving you information. We have built successfully, and you can see how much memory it's going to use. I do want to scroll back up. We do see this warning about linking scripts being depreciated. They want us to use board build LD script. So I'm going to copy this line, and I'm going to go back to my PlatformIO. We currently have that in a WL-T build flag. Just underneath upload reset method, doesn't matter which line as long as it's not in build flags. I'm going to paste that board build LD script. I'm going to do an equal, and I'm going to take everything after the T, this eagle.flash.1meg256.ld. I'm going to cut it and paste it right there. And then we can take out the -WL, -T. We don't need it. And we can delete this space. It should work exactly the same, but I wanted to go ahead and update it in case people were curious what that warning was telling you about. So I'm going to go ahead and build again just to make sure it still works. And we've built it successfully with our update. So we should be ready to go ahead and upload it to our chip. So with your writer all cabled up to your ESP module, go ahead and plug your writer into your USB port on your computer. If we take a look in Control Panel, Hardware and Sound, Device Manager, look under COM ports, you should see your writer as a USB serial CH340. Mine is on COM 10. VScode and PlatformIO is going to know this, but if you don't have a CH340 driver installed, your writer might not work. I have a video on how to install one of those in case you need to, but it's very straightforward, and I will leave a link to the CH340 driver in the description below. Just make sure that it knows it as a CH340. So we corrected that syntax, and now we're cabled up USB to our writer, but there are a couple of things in this file to be aware of. Most of the time, it's going to work with defaults. Now with this BigtreeTech writer, I have found that the upload reset method doesn't work quite correctly. What this does is it tells it how it's going to reset the board before and after a flash of a module or a chip. The CK does a soft reset on the before, and for some reason this writer does not like that. But you have a couple of different options. So if you set CK to node MCU, that will perform the resets that this writer likes to be able to flash one of these ESP chips. Also, some of these other options, like board ESP12E, that's not the board we're using, but it will work to flash a lot of these ESP boards. But you can go look these up and make these corrections if you wish. Just with that node MCU change right here on the reset method, you can upload. It will work. In fact, let's just go ahead and do it. So we made a change to the INI file, so we have to build. But once the build is completed successfully, we can go ahead and hit upload. You can see it is writing to that ESP module. I'll show you what that module and the writer does while it's uploading, but it is working correctly. Even though a lot of these options aren't exactly correct. If you would like to adjust these to make them correct for your board, just to rule out any inconsistency, you can look those up. So let's pop open a browser. Let's search for PlatformIO ESP8266. And we'll just go to this first one right here, the documentation. And let's just click on boards. Here are all the different boards that are supported under this 8266 environment. If we scroll down a bit, we'll come down to the expressive section. We just have a generic ESP8266 module. Ours is the ESP01, but it is the 1 meg flash, this guy right here. And you'll notice it has an 80 megahertz frequency. You can click on this, and this gives you all the correct information that you can enter for that module. For instance, the board name. So we can copy ESP01 1 meg, go back to PlatformIO, and that is the correct board name. The chip frequency is actually 80, so we can change that up as well if we'd like. We'll just change this 160 to 80. Again, other than the stuff we changed, the reset method and the board build LD script, it doesn't really matter, but it might be good to change these things just to rule some issues out. All this information is on the PlatformIO website. So let's just go ahead and flash one more time so I can show you what it's going to do. We'll hit upload. Upload will build and upload at the same time. And while it's uploading, your green and red lights on your writer are going to flash, and your module will flash occasionally, just that one LED. Also, if you're having issues while you're uploading or building, it's always a good idea to come over here and erase your flash. This will clear everything out on the chip. Also, if you need more info, you can enable verbose build and verbose upload, so it'll spit out everything that it's doing while it's trying to build or upload. These are handy tools to have. But we have successfully uploaded the application, the code part, for ESP3D. Now we need to upload the side file stuff, the stuff that represents the UI, the things you can see in your browser. And PlatformIO has you covered there as well. All you have to do is hit Upload File System Image. It's going to know that there is a file system. If you head back to Explorer, in your data directory, that's all your file system information. The website portion, back to PlatformIO, we can just hit Upload File System Image. And since we have this board build LD script that tells us what size the flash is, it knows where it's going to put it. So we'll just click it. And we did go to 100% complete on the upload. So it did upload all that information correctly. I'm not sure why it gives you this error and says failed. It has something to do with how it exits and resets that chip. I can't figure out a combination of syntax that makes it run clean, but it does work correctly. It has uploaded successfully. So now we can take all the wires off our ESP and plug it into our SKR board that's on our SK Go printer. Our newly flashed module will plug into our board right here, just like that. And then we can power our printer up. With the printer powered up, that ESP module is going to be in access point mode, so we have to log into it to configure it. So from a wireless device, sometimes I use my phone. This computer does have a Wi-Fi interface. I can go down here and click on the network icon, and you'll see ESP3D. That's your new module. We'll click on it and we'll connect. It does need a password. That is 12345678. I've already entered it, so I shouldn't have to enter it again. Once you're connected, it should pop open a browser and go to the interface where we can configure the ESP3D software. If that browser redirect doesn't work, the default IP is 192.168.0.1. And that will start the setup process for ESP3D. I'm going to take English, hit Start Setup. My printer's firmware is Marlin. We'll hit Set. My printer board's baud rate, we're going to go ahead and take 250,000 because that's the maximum. We want it to be as fast as we can go. We'll hit Set. And my device name, this is kind of important for later. I'm going to call it the printer name, SK Go. And we'll hit Set. We'll continue. Access point mode is the default mode where we have to connect to it. We want it to connect to our existing network. So we'll change it to Client Station, hit Set. Down here, we can scan for wireless networks. Go ahead and hit the magnifying glass. This is my network right here. I'm going to join, hit Set, and then enter your password and hit Set. Then we can hit Continue, and then we can hit Close, and that's going to take us to the interface of ESP3D. Now we haven't rebooted yet, we're not on our main network, we're still on that access point. We have to kick it over for those to be enabled, but if you need to make other changes, you can from here. So you can go up here to the right, to the menu icon, you can change your setup if you'd like. You can also check your printer config. If you go to printer, and you hit recycle, notice that we're not connected to our printer. That's because we're going to have to make some changes in Marlin to be able to talk to it. But from the Wi-Fi portion, we're looking pretty good. Let's go ahead and reboot the printer. We'll make sure we're connected again to the main wireless network, not the printer's wireless network. And if everything works correctly, you can go to that printer by its name. We named it SKGo, and you need a .local after it. And here's your interface for ESP3D. Now this should just work with Windows. There are extensions in Windows that should make you able to communicate with these .local devices. If it's not working correctly, you can try to install Bonjour. Those are some file and print extensions. I show these in other videos. I'll leave a link. That might help you to be able to connect like this. But if all else fails, you can either look in your router for the IP of your new printer, or you can use something like an IP scanner to see what new IPs have shown up on your network to try to determine what the IP is of this new ESP module. But hopefully you can use this .local address and you don't have to mess with any of that. So our ESP3D configuration is pretty much complete. BigtreeTech does this a different way. They don't do it with VScode like I show. They use this flash download tool. I'll leave a link to it as well, but let's just open it up and we'll go developer mode, ESP8266 download tool, and in here you can just select the COM port of your writer and the bin file that BigtreeTech gives you for this ESP3D software, and that will upload it to your flash, but it doesn't upload that side file information. If you take a look at their documentation, after you flash that firmware, you're going to have to go into that EP mode, that 192.168.0.1, and upload the files for the UI. There's some HTML files. I can never get that process to work. It never allows me to upload this index.html.gz file. If that's the route you want to go, by all means go ahead, but I think it's a lot easier with VScode because you don't have to mess with any of that. Just another option if you want to go with the way that BigtreeTech does things. Now we need to head into Marlin and change our configuration up so that we can connect to our printer with our ESP3D software. So back into VS Code, I'm just going to right click, add folder to workspace, and I'm going to go add my Marlin config for this SKGo. Remember, you just want the parent folder of the VS Code folder, that .vscode right here. So this one, hit add, and I can expand Marlin, and we'll open up configuration.h. And we need to change the serial ports up just a bit so that we can access the serial interface on the board with that ESP8266 module. So the first serial port, I always set it to -1. That's so you can use that emulated serial device on these 32-bit boards. But in this case, I'm going to change it to 3. You'll see here in just a second, but this LPC1768 is treated as an Arduino framework, and it has 4 UART configurations defined to it by default. Those are the different serial connections. We're going to use number 3 because it's currently not used by anything. And then down here on serial port 2, we're going to take the comment off of that line. We're going to leave it as -1 so we can still use that emulated serial. So we can connect up via USB. I am assuming you have a Marlin config that works for your printer. We're just making the changes that we need to make to use that Wi-Fi module. Everything else should be working. But right now, just with those 2 changes, if you go over the PlatformIO icon and you head to LPC1769 and you just hit build, it should build clean. We are successful. Now on this framework, this LPC176X, that's for 8 and 9, there are 4 different UART connections or serial connections configured in that framework. But just to show you what the different serial connections are, I'm going to change this one over to 1, and then we'll hit build. We get failed and a bunch of errors. You can see serial port pins 1 conflict with LCD pins. So that serial configuration is already in use. What if we change it to 2? We'll hit build. Serial port pins 2 conflicts with E-stepper pins. So that serial is already in use. It's probably not just the E-steppers, it's probably all of the steppers for the UART bus. So you can use the smart drivers. So that's why we're going to go with 3. So serial port 3 for communicating with the Wi-Fi module, -1 for communicating with that USB interface on the board. So here's where things get just a little bit tricky. We're actually going to have to go in and edit that framework. I tried to find a way to do this in the INI file, but I wasn't able to, so we will have to edit that file manually. But let's take a look at the back of the board first. You'll notice on that Wi-Fi port, you have a couple of pins labeled there. You have a 4.28 right here, and then a 4.29 over here. Those are transmit and receive pins. You'll notice on the pins right above it, these are your TFT pins for your screen. We also have 2 pins, 0.2, 0.3. Those are also serial pins. And I mention these pin numbers because we're going to have to know these to edit that framework. So back to the computer, we're going to have to go edit that framework file. So we'll open up Explorer, we'll open up Users, my username, .PlatformIO, Packages, and here's where the framework files live. Every time you compile a different type of board, it's going to pull in that framework automatically with PlatformIO. It'll download it. You can see we have one for an ESP8266, but we have one for our LPC176X environment for our SKR board. So we'll go into this framework. We're going to go into Cores, Arduino, and we need to take a look at hardware serial.h. If you scroll down just a bit, you're going to see all the different configurations for the UART connections. You can see we have 0, 1, 2, and 3. You can see we have different pin numbers that are assigned for each one of these different configurations. We're mainly concerned with 3 because we know that's not in use. The comment never got updated for this, and that usually doesn't bother me, but for some reason in this case it does, so I'm going to go ahead and update that on mine. We'll just change it to 3. We're going to change the pin config function number to 3. We need 2 pins to make this work. The first pin, this pin config pin number, we're going to change that to 28. Then the port number, we saw that on the board, it's port 4. And then our second pin down here, we're going to change that one to the 29 pin. So that represents the port 4.28 and 29 that we saw on the back of the board. So that will enable us to use this UART3 for that 4th serial connection. So we can save this file. We'll head back to VScode. We'll change our serial port back to 3. By the way, you can use this back and forth. It doesn't matter which one of these you set. This one could be -1, this one could be 3. It will work either way, just whichever way you wish. But we go back to serial port 3 and we're going to hit build. And our build succeeded. Now before we upload, there is one more thing that I want to go over, and that's in configuration_adv.h. So we'll jump back to the Explorer. We'll go into configuration_adv. And just search for Wi-Fi. Marlin does have some embedded Wi-Fi support, but I'm not really sure in what capacity they use this. Since we're using ESP3D, there might be some commands that Marlin can use, like from your touchscreen, to interact with it, but at this point we're really just using it as a serial connection from ESP3D over to our board directly. So we don't really need these features. We might explore these at a little later time, but we don't need them for this config. Just making those serial changes and updating our framework should be enough to make it work. I just wanted to mention that. Now we can go ahead and upload to the printer board. The printer is powered on. I am cabled up USB underneath my LPC17669 and my PlatformIO. I'm going to hit upload. The upload succeeded. Now I'm going to power off and power on the printer one more time. Now we can head back to the browser and check out our ESP3D. We'll just hit refresh. And if we go back to this printer tab, we can hit refresh here. And now it pulls in all the information on our Marlin board. Anything that can be adjusted in EEPROM can be adjusted right here. You just hit set and it will save it. We can head back to the dashboard. We can turn our heater on if we'd like. If you don't see certain settings about your printer, like the bed temperature doesn't appear right here, we can come back up here to the menu. We can go to preferences and we can enable some of these things, like if you have mixed extruders, but we'll just enable fan control and bed control. You can adjust your feed rates for manual movements when you're controlling your printer with the ESP3D module. So let's hit save. And now we have control for our bed. We can turn it up to 60. Now you'll notice it wasn't very quick to pull these changes in. You can change how often it will auto check that. You can just check this box up here. And now it will plot it every 3 seconds like you're used to with something like Octoprint. And at this point, once you're connected up, it will show your IP on the LCD screen, but it doesn't seem to do that until after you have everything all set up. So it might not be that helpful at the beginning. You might still have to scan for that IP, but if for some reason your .local address stops working, you can probably grab the IP off your screen at this point. Now here's the only real downside to ESP3D. It's how long it takes to upload files to your SD card. I'm going to go ahead and mount my SD card on my LCD screen, and then we can hit refresh down here, and it'll bring in all the files that I have on that card. And there are limitations. This file system feature on ESP3D has the old DOS limitations. So that means the file name can only be up to 8 characters, and the file extension can only be 3. So anything that you have named G-code, you're going to have to shorten that to GCO. They'll still work the same, but they won't upload and you can't use them with this software if you don't. So let's just grab a random G-code file. Here's my SKGo probe mount. Let's just rename this guy. We'll shorten the file name down to 8 characters. We'll just call it skgo-z, and then we'll take the DE off of G-code. We'll hit enter, and let's check and see how big this file is. It's 941K, so a really small file. Let's pull up our Google stopwatch here. I'm going to hit upload on the ESP3D. I'm going to find my skgo-z file. I'm going to hit open, and I'm going to hit start. So we're 1 minute in and we're only 17% done. So this is definitely the downfall of using the ESP software and these 8266 devices. It's super slow to get things stored over on your SD card. So as a monitoring tool, it works really well. If you're the kind of person that still uses their SD card to load files and you just want to monitor your printer with this tool, it works great. But I wouldn't suggest trying to upload things to it because it does take forever. So a lot of you are probably thinking, what's the point of this module if I can't upload files to it quickly and print them? Well, if you're still using the SD card method like a lot of people do, and you just want built-in monitoring, these might be kind of handy. If you have an SKR 1.4 board or one of these touchscreens, you already have the port, and they're pretty easy to set up, and the modules don't cost much money. So it might be convenient for some users. But in my opinion, it's nowhere near what Octoprint is, and definitely not a replacement for it. So keep that in mind. Now let's get this same module set up on the touchscreen so I can show you if there's any differences in the Marlin config. I'm going to use the same module. I just took it off my SKR 1.4 board, and like I showed you before, they just plug into these pins right there. And down here is where you plug in your TFT wires that will hook to your board so you can use your screen. On the SKR board side, this pin right here is the 5-volt pin, so that's how the pins need to line up onto your screen. I'm just going to plug all my wires in just like this. If you have the same cable that I do, you have the wider dash, that's 5-volt, and the really small dash marks, that's the reset line. You can always just line up what it says on the screen and what it says on the back of the board, just to be sure you have the right wire going to the right port. We have it in touchscreen mode, and you'll notice it says no printer attached. I'm going to go into settings. I'm going to make sure and confirm we're set to 250,000, because that's what the printer and that Wi-Fi module are set to. And back to VScode, I'm going to change up the serial ports again. This first one here, I'm going to change that to 0. So that will allow the screen to talk to the board. And serial port 2, I'm going to leave it at -1. That should allow you to still communicate with the printer via USB. So let's go ahead and re-upload. Upload's complete. I'm going to power cycle the printer. On the screen, you can see it's connecting up to the wireless. It's going to give you the IP, and that printer not connected message has gone away. We can go ahead and press confirm. Now we can once again control our printer with our touchscreen. We're all connected up. We can hit preheat. Let's do PLA. You can head into heat, and you're getting updates. So we are controlling the printer with the touchscreen successfully. And if we go back to our browser, let's reload our SKGo ESP3D interface. We'll just click on auto check, and you can see we're once again getting updates from our printer. So the Wi-Fi module attached to the screen is working successfully. And with any luck, we can go to printer face, and we can hit connect, and we can still use our serial interface to talk to our printer. So this should tell us that we can use touchscreen and something like Octoprint side by side if you'd like to. So hopefully that's everything you need to know to get up and running with ESP3D software and a Wi-Fi module. You can use these modules on pretty much any printer board as long as you have a transmit and receive pin available and you're only pushing 3.3 volt to that module. 5 volt won't work for these 8266s. Now, the SKR 1.4 board and the touchscreens like MKS and BigtreeTech make it a lot cleaner install because they have a dedicated Wi-Fi port. Also, the BigtreeTech chip writer makes things a lot easier than using something like an Uno. And I will reiterate one more time, this is not a replacement for Octoprint. In my opinion, it doesn't work near as well as Octoprint does, especially when transferring files. Hopefully you found this helpful. If you did, please consider giving it a thumbs up or subscribing to my channel. If not, leave your thoughts in the comments below. And as always, thanks for watching.